Welcome to Tungal online classes. Today we are going to discuss the remaining numericals of electromagnetic induction. In the last lecture we completed the numericals up to 6.6. Now we are going to discuss the numerical number 6.7. So in this 6.7 numerical, first we will see what they given. So here they mentioned that a straight wire of 10 meter long is extended from east to west. So what they consider here, wire is considered, that wire will be taken. So I am assuming that this point is towards the east and this point is what, west. So the length of this rod is equal to what, 10 meters. The length of this rod is equal to what, 10 meters, and this rod will be falling vertically downwards. The rod will be falling what, vertically downwards, and which is falling with a speed of what, 5 meter per second, 5 meter per second, right angles to the horizontal component of earth magnetic field, whose magnetic field intensity is given by 0.30 into 10 power minus 4 Weber per meter square. So here they mentioned three different physical quantities. First they mentioned the length of the given rod. So we will write the given data here. First we have to solve the part A. So to solve the part A, first we will write the given data. The length of the rod is equal to, the length of the rod small l is equal to 10 meters they given, 10 meters they given, and the velocity magnitude will be given by 5 meter per second, and the horizontal component of earth magnetic field will be given by 0.30 into 10 power minus 4 Weber per meter square. So this is the given data. What they given? Length of the rod is given by 10 meters and the speed will be given by 5 meter per second, and BH value is equal to, what is the BH here? Horizontal component of earth magnetic field. That value is equal to 0.30 into 10 power minus 4 meter per second square. Now what value they are asking? They are asking the EMF induced. So already we know that the concept of the motional EMF, when the motional EMF will be existed, whenever a moving rod will be cuts the magnetic flux, at that time EMF is induced across the length of the given moving rod. Such EMF we are calling as a what? Motional EMF. So here we know the formula for the motional EMF. So what is the formula for the motional EMF? Motional EMF E is equal to what? Motional EMF E is equal to what? B into L into V. B into L into V. So already I told, while you are deriving the expression for the motional EMF, all the three physical quantities, the magnetic field intensity, length of the conductor, and the speed of the moving rod or the velocity of the moving rod are always mutually perpendicular to each other, so that then only you are getting the maximum motional EMF. So first we will calculate the magnitude, then after we will be discussing about the direction of the induced EMF. So here E is equal to, what is the B value they mentioned? 0.30 into 10 power minus 4, 0.30 into 10 power minus 4, and what is the length of the given rod? 10 meters, and what is the speed of the moving rod? That is equal to what? 5. So if you simplify 0.30 into 10 power minus 4 into 10 into 5, you will get 1.5 into 10 power minus 4 volt. So what is the motional EMF value according to the given question A? what is the instantaneous value of the EMF induced in the wire. So whenever the moving rod will be what? How the moving rod will be moving? That moving rod will be moving in the vertically downward direction. What is the direction of the magnetic flux? The direction of the magnetic flux will be acting horizontally. So whenever the rod will be moving in the vertically downward direction, so it will be cuts the magnetic flux. It will be cuts the magnetic flux. So whenever the rod will be cuts the magnetic flux, motional EMF is induced. The magnitude of the instantaneous EMF or the motional EMF value will be given by E is equal to 1.5 into 10 power minus 4 volt. So it is a very simple. Already we know the given data values. Already you know the direct formula E is equal to BLV. Simply you will get the magnitude of the instantaneous EMF. Now what they are asking in the second and third questions is, what is the direction of this EMF? What is the direction of this EMF? So already we know that whenever the induced EMF is produced either due to the change in the magnetic flux or due to the magnetic field lines will be cut by the moving rod. So to find the direction of the induced EMF or induced current, we are going through one law, that is nothing but Fleming's right hand rule. Or to find the direction of the induced EMF, we also following the cross product. Now we will discuss. Once again see what is the given data here. They mentioned that the length of the given rod is given by 10 meters and it is moving with a speed of 5 meters per second, and in which direction the rod will be moving, that is a very important to find the direction of the induced EMF. See here, we are assuming that this end will be assuming as east and this end will be taken as a what? West, and the magnetic field lines or the direction of the horizontal component of earth magnetic field is always directed from south to the north. Once again, what is the direction of the BH? The direction of the horizontal component of the earth magnetic field is always acting from where to where? South pole to the north pole. So here I draw one diagram. So according to that, the rod will be extended from where to where? East to west. That means what? The length of the rod will be measured, the length of the rod L will be measured from where to where? From east to west. The length of the rod will be always to be taken in the direction of east to west. So suppose we assume displacement vector. So if you want to measure the displacement vector, you must mention its direction. So like that, here I am assuming that the length of the given rod will be as a vector quantity. So whose length will be measured from where to where? East to west. Next, what is the direction of the BH? I told the direction of the BH is always from south to the north pole. So what is the direction of the BH will be acting? The direction of the BH is always acting from south to the north. And what is the direction of the velocity? Velocity V bar will be acting in the vertically downward direction. So how the rod will be moving? Vertically downwards. So here, to find the direction of the induced EMF, we follow two different methods. One is Fleming's right hand thumb rule, or we have to follow the vector cross product. So to find the direction of the induced EMF, here I choose the method vector product. So here the representation of the motional EMF, will be changed in the form as. So generally what you know the formula for the motional EMF, E is equal to BLV. So EMF is a scalar quantity. This induced EMF can be written as L bar dot V bar cross B bar. So the another form of representation of the motional EMF is equal to what? L bar dot V bar cross B bar. So in which direction E will be existing means the direction of motional EMF is existed in the direction of V bar cross B bar. So in which direction the direction of the induced EMF will be existing means in the direction of V bar cross B bar, the direction of the direction of the motional EMF will be existing. So here to find the direction of V bar cross B bar, I am assuming that a three-dimensional plane. Three-dimensional plane. So here it is the x-axis, y-axis and z-axis. So z-axis means what? Z-axis will be always acting vertically upward direction. So this direction will be taken as what? X-axis, and it is what? Y-axis. This is what? Z-axis. So here from the diagram BH direction will be acting from where to where? South pole to the north pole. So that I am assuming that the horizontal component of earth magnetic field will be acting along the positive x-axis. The horizontal component of earth magnetic field will be acting along the positive x-axis. Next, already I told the length will be measured in the direction of from where to where? East to west. Length will be measured from where to where? East to west. So L bar will be acting in which direction? Along the positive y-axis. So here L bar will be acting along the positive y-axis. Next, one more physical quantity is there. So what value you need here? V bar. What is the V bar? The direction of the velocity. Of the given metallic conductor. So the direction of the velocity of the conductor will be in which direction? Vertically downward direction. If you take the vertically upward direction, that is what? Positive z-axis. Vertically downward direction means what? It is a negative z-axis. So that the direction of V bar will be acting along the negative z-axis. So this is a representation of directions of three different vectors, BH vector as well as length vector as well as the velocity vector. But what you need here, you have to find the direction of V bar cross B bar. So the direction of V bar cross B bar will be calculated as. So to represent the direction of any one of the vector, we find its unit vector. So here V bar will be acting in which direction? Along the negative z-axis. So the unit vector along the negative z-axis is what? Minus k cap. And B bar will be acting along which direction? Positive x-axis. So that the unit vector which was present along the x-axis will be given by I cap. Now, so minus I will be took as a common. This is a k cap cross I cap. The k cap cross I cap is equal to j cap. Why? The basic. I cap cross j cap is equal to k cap. J cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. So these are the basics in the cross product, so that k cap cross I cap is equal to j cap. Before minus will be there, so that minus j cap. Minus j cap is what? minus j cap is the unit vector along the negative y axis. So that v bar across b bar will be acting along the negative y axis. Negative y axis. If v bar across b bar will be acting along the negative y axis, so the direction of induced EMF, is also acting along the negative y axis. But they didn't given the x axis, y axis, z axis. Negative y axis means what? From west to east. According to this diagram, east to west will be assuming as the positive z axis, positive y axis. So here negative y axis meaning is what? The induced EMF will be acting from where to where? West to east. So that the required answer is the direction of the induced EMF is acting from west to east. The direction of the induced EMF is given by what? West to east. So this is the calculation of the direction of the induced EMF according to the cross product. Or we will also calculate its direction by applying the Fleming's right hand rule. What is the Fleming's right hand rule? Thumb will be representing the direction of the motion of the conductor and forefinger is indicating the direction of the magnetic field and the middle finger will be indicating what? Direction of the induced EMF. So here see, if a thumb will be acting in the vertically downward direction means which is representing the direction of the motion of the conductor, and so this is indicating south to north, that what we assumed earlier, and in this direction, so this is indicating what? Direction of the induced EMF. So what we consider, this point is a what? East, and this point is a what? West. So the middle finger will be indicating what? West to east. So on the third one is, in this given problem, which end will be maintained at high potential region? Which end will be maintained at the high potential region? To understand this also already we solved. So which end is maintained at higher potential and which end is maintained at the lower potential? So while in the derivation of the motional EMF, this type of diagram we drawn, this end is a P, this end is a Q. If the field will be acting into the plane of the paper, so the induced EMF is developed across the ends of the conductor. There you told that the induced EMF is moving from the induced EMF direction from where to where? Q to the P. Hence you taken the P will be maintained at the high potential region, Q will be maintained at the low potential region. So that from this, the direction of the induced EMF, is always from low potential region to the high potential region. So according to our given problem, the direction of the induced EMF is from where to where? West to east. So this is the west, this is the what? East. The direction of the induced EMF is directed from where to where? West to east means the west will be maintained at low potential and east will be maintained at the high potential. East will be maintained at what potential? High potential. So that the end which is in the direction of the east, the end which is towards the east will be maintained at high potential region, and the end which is at western side, that is maintained at the low potential. So this is the numerical number 6.7. Next problem number 6.8. They mentioned that a current in a given circuit, falls from 5 ampere to the 0 ampere. That means initial current value is equal to how much? 5 amperes, and the final current becomes to what? 0 ampere. That was takes place in a time interval of 0.1 seconds. So first we will write the given data. Initial current value is equal to 5 ampere. Final current value is equal to 0 ampere. in a time of dt seconds is equal to what? 0.1 second. 0.1 second. So, due to the change in electrical current in the given coil, an EMF was induced in the coil, that value is equal to 200 volt. So, induced EMF small e is equal to what? 200 volt. So, what they are asking? Estimate the self-inductance of the given coil. Self-inductance of given coil. Self-inductance or the coefficient of self-induction is denoted with the symbol of capital N. So, here this is based upon the concept of self-induction. So, in the self-induction we wrote one formula, coefficient of self-induction formula you wrote. So, from that induced EMF E is equal to L into di by dt. Induced EMF what? The magnitude of the induced EMF is equal to what? L into di by dt. So, here induced EMF value will be given by what? 200. Induced EMF is equal to how much they given? 200. L value we don't know. So, di means what? Change in electrical current. So, that is equal to 5 minus 0, that value is equal to what? 5, and time interval is equal to what? 0.1. So, they given the induced EMF value, that value is nothing but 200. L means what? We are going to calculate the L value. Change in current is equal to what? 5. Time interval is equal to what? 0.1. So, here, so 200 is equal to L into 50. So, if you simplify, so that is equal to what? L is equal to 4 Henry. L is equal to what? 4 Henry. So, once again see here, what is the time interval here? 0.1. Change in current is equal to 5 minus 0, that is equal to 5. dt value is equal to what? 0.1 second. So, that is a 10 power minus 1. If it is going to the numerator, it value becomes to what? 50. 50 4s are 200. So, therefore, L value is equal to what? 4 Henry. That is problem number 6.8. Now, the previous problem is based upon the concept of self-induction. Now, this given problem is based upon the mutual inductance. Already we know that. What is the mutual inductance? Whenever the current value will be changes in one coil, due to that the flux will be linked with the another coil. As a result, the induced EMF is produced in the secondary coil. Such a phenomena we are calling as a what? Mutual induction. So, here they mentioned that the coefficient of the mutual induction value will be given. So, what is the coefficient of the mutual induction? Capital M is equal to 1.5 Henry they given. So, capital M is equal to what? 1.5 Henry. So, Henry is the SI unit of either coefficient of self-induction or mutual induction. Next, the current value will be changes in one coil from 0 to 20 amperes. So, the change in electrical current value, if you assuming as a di, the di value is nothing but 20 amperes. So, already we know that in the phenomena of the mutual induction, the current will be changes in the primary coil. The current value will be changes in the primary coil. Induced EMF was induced in the secondary coil. So, the change in a current in the primary coil is equal to how much? 20 amperes. In what time interval? 0.5 seconds. So, therefore, dt value is equal to 0.5 seconds. Now, what they are asking? The change in a flux. What value they are asking? Change in a flux will be they are asking. So, we know that induced EMF is equal to small e is equal to minus d phi by dt. Small e is equal to what? Minus d phi by dt, and this value is equal to minus m into di by dt. So, what is the formula for the induced EMF? Induced EMF is equal to negative rate of change in magnetic flux. That value is equal to again minus m into di by dt. So, from this dt will be getting cancelled. change in flux d phi is equal to m into di. What value they are asking? They are asking the change in flux value. Change in flux value. So here d phi by dt is equal to m into di by dt. dt will be getting cancelled. So change in flux is equal to what you got? M into di. Therefore d phi is equal to, what is the value of m? So m value is equal to what? 1.5 Henry, and di, what is the change in a current value? 20 amperes. 20 amperes. So this is a what? 15 into 2, 30 Weber. So the change in flux value is equal to how much? 30 Weber. So this is a required answer for the numerical number 6.9. Coming to the numerical number 6.10. In this problem they mentioned that a z plane is traveling towards west. They consider one plane is traveling, that a plane is traveling from where to where? East to west. That only they mentioned. The plane is traveling towards west at a speed of 1800 km per hour. So first we will write the given data. So the motion of the plane is from where to where? East to west. The motion of the plane is what? East to west. So if we assume the plane will be traveling from east to west. So this is the east and this is the west. We assume it is the plane. So whenever the plane will be traveling from east to west, the wings of the plane will be in the direction of south to the north. Here what point we have to understood? Even though the plane will be traveling from east to west, here who are cuts the magnetic flux means, who are cutting the magnetic flux means what? The wings of the plane will be cutting the magnetic flux. So what point we have to understood? The wings of the plane will cuts the magnetic flux. So if the wings of the plane will be cutting the magnetic flux means, once again we have to see which component of the earth magnetic field we have to consider. Already I told that the horizontal component of earth magnetic field will be, always existing in the direction of the south to north. So here the wings of the given plane is also in the direction of the south to north, and the horizontal component of the earth magnetic field is also existing in the south to north direction. Means these wings does not cutting the magnetic field lines, which are existed due to the BH, so that the wings will be cutting the magnetic field lines of which component means the magnetic field lines will be cutting the magnetic flux, due to the vertical component of earth magnetic field. So that here which component of the magnetic field we have to consider means, we consider the vertical component of earth magnetic field. So if B will be indicating the earth magnetic field, the vertical component of earth magnetic field will be given by, BV is equal to B into sin delta, where delta is called what? Angle of dip. So here to calculate the induced EMF, to calculate the induced EMF which is existing across the wings of the given plane, which component of the magnetic field we have to consider? Vertical component of this earth magnetic field. So the vertical component of the earth magnetic field will be acting vertically upwards, and the length of the air wing will be acting from south to north, so that this length will be perpendicular to the vertical component of the magnetic field, and the velocity will be acting from east to west. This velocity is perpendicular to the wing, and this velocity is also perpendicular to the vertical component of the earth magnetic field. Already I told, while you are considering the motional EMF, L is directed from where to where? South to north, and BV will be directed vertically upwards, and the velocity is from where to where? East to west, so that all these three components will be mutually perpendicular to each other. So here, now how can we calculate the magnetic field from magnetic induction? How can we calculate the induced EMF means? So the induced EMF E is equal to, generally we are writing the formula E is equal to B into L into V. So here, which component we have to consider? BV. So induced EMF E is equal to BV, vertical component of the earth magnetic field, into length into V. So what is the BV formula here? You wrote B into sine delta into length into velocity. So here they mentioned the earth magnetic field intensity will be given by 5 into 10 power minus 4, 5 into 10 power minus 4, and the angle of dip is equal to what? 30 degrees. Angle of dip is equal to what? 30. Sine 30, and the length of the wings is equal to how much they given? 25 meters. So the L value is equal to 25 meters, and the speed value, what they mentioned here, what is the speed of the aeroplane? 1800 kilometer per hour. So we have to convert into meter per second. So this becomes to what? V value is equal to how much you will get? 500 meter per second. So in the place of V, we have to write 500. If you simplify all these values, so what is the sine 30? Sine 30 value is equal to 1 by 2, that is a 0.5 into 25 into 500. If you simplify this value, you will get the induced EMF value is equal to what? 3.1 volt. 3.1 volt. So these are the numericals of electromagnetic induction. Now this topic is completed. In the next class we are going to start alternating current. Thank you.